Hello. Last lecture we discussed authentication of IKEv2 using pre-shared key. In this lecture we will look at authentication using certificate authentication or signatures. Before we get into it, let's just make sure we are all clear on the process. So, the whole premise of certificate authentication is that what gets encrypted by the private key gets decrypted by the public key. The private key has to be safeguarded, of course. If you are the owner of the certificate, you are the only one holding the private key. Whatever you encrypt using your private key gets decrypted by the public key, proving that the message is authentic. So, in this example, we have two sides authenticating using certificates. Side A and side B, each side hold the private and public key or cert. Side A wants to send a message to side B proving beyond a shadow of doubt that the message origin is side A. Side A would encrypt the message using side A private key. It will send it to side B, which would decrypt using the public key of side A. By decrypting using the public key, this would serve two purposes. The first purpose is that side gets the original message. The second purpose is for non-repudiation, meaning that side A cannot say I didn't send the message as it's the only entity that has that private key. Same with side B, when side B sends a message to side A, side B encrypts using the private key of entity B. B sends the encrypted message to A, which would in turn decrypt the message using the public key of entity B. It will then get the original message, which serves also the purpose of non-repudiation. It's a proof that side B is indeed the origin of the message. Now let's go back to the topic of our discussion. In the previous lecture we understood how the two sides generate a signed octets output. The initiator and the responder are able to calculate the other side's signed octets. Meaning that the initiator is able to calculate responder signed octets and the responder is able to calculate the initiator signed octets. Now, the difference between pre-shared key and certificate authentication is that each side hash the signed octets and encrypt using its own private key. So, the initiator encrypts the hash of the initiator signed octets using the initiator private key, and the responder encrypts the hash of responder signed octets using the responder private key. When the responder gets the auth from the initiator, it uses the public key of the initiator to decrypt the auth message. It gets a value, let's call it X. Now it calculates the initiator signed octets and then it calculates the hash of the initiator signed octets. If the decryption of the message received by the initiator result in the same value of X, then this authenticates the initiator. The responder does the same thing, it calculates responder signed octets. It will then hash the signed octet and encrypt the outcome using the responder private key. It will send the output to the initiator. The initiator would use the public key of the responder to decrypt the auth payload. If the output of the operation is equal to its own calculated hash of responder signed octets, then the responder was authenticated. A picture is worth 1,000 words. Let's take a look at it again here using this visualization. We see side A and side B. Side A and side B have the private public key pair. Side A would hash the initiator signed octets and encrypt it with side A private key. It sends the output to the responder. The responder would decrypt using the public key of side A. It gets what should be the hash of initiator octets. It calculates the hash of initiator octets. If the calculation is equal to the decrypted value, then side A is authenticated. Side B would hash the responder signed octets and encrypt it with side B private key. It would encrypt the outcome and send it to the initiator, which is the auth payload. Side A, the initiator gets the encrypted hash. It decrypts it using side B public key. It would get what should be the hash of responder signed octets. It will then run the same calculation by hashing the responder signed octets. If the calculation operation and the decryption of auth yield the same result, then side B was authenticated. Hopefully this was helpful. We will discuss more in the next lecture.